So my name is Melissa, and I will be discussing a molecular orbital theory example. So what you might see, just an example of a problem of where you might use the molecular orbital theory. So to begin, we have page 43, number 6 of the Quiz 2 prep in the green workbook, and the question reads, using molecular orbital theory, list the following molecules from shortest bond length to longest bond length. And these molecules are B2+, B2, B2-, and B2-2-. So what you want to keep in mind is that boron has less than 8 protons, and that comes into play when you are drawing this diagram here. So you can see here, if the molecule were to have more than 16 protons, then the sigma would actually be higher in energy than the 2 pi here. So, to begin, just to give you a little clarification of my diagram here, I have color-coded based on increasing number of electrons. So with the B2+, the black one here, we have 1, 2, 3, 4, 5, and that gives it a +1 charge. You can see on the left here, it's 1, 2, 3. That's what a regular boron atom would have. And 1, 2 here, that gives it the +1 charge. And for B2, since that has a neutral charge, it's a regular boron. Both of them are regular borons. What you do here in my diagram is you just add the preceding color. So the black and the blue would be B2. B2- would be represented by the black, blue, and pink here. And B2-2- would be represented by all the colors here. So B2-2- would have the 1, 2, 3, 4, 5, 6, 7, 8 here, and 1, 2, 3, 4, 5, 6, 7, 8 here. And when filling out this diagram, you want to make sure that you fill each energy level preceding first, and that each level is filled before you pair the next electron. As you see here, the order that I filled this out would be black, then blue. So I put 1 here and 1 here before I put the pink here, which gives this a bonding pair and this a non-bonding pair. So that's my diagram there for that, and that's what you would get for each different molecule here. There you go. Okay, moving on. For bond order, the bond order is equal to 1/2 the bonding electrons minus the antibonding electrons. And the antibonding electrons are the ones located in these levels here with the green stars. So, if you were to calculate the bond order for B2+, it would be 1/2 the 3 bonding electrons, which you see here, 1, 2, 3 black, and the 2 antibonding electrons, which you see here, 1, 2, antibonding, and that would give you a bond order of 0.5. And if you continue to use this little equation to figure out the bond order for B2, B2-, and B2-2-, you see that the bond order actually increases from 0.5 to 2 by 0.5. You see B2+ has a bond order of 0.5, B2 has a bond order of 1, B2- has a bond order of 1.5, and B2-2- has a bond order of 2. What you need to remember is that as bond order increases, bond length decreases. So from shortest to longest bond length, the answer to this question would be B2-2-, B2-, B2, and B2 plus. And the bond orders, remember, would be 2, 1.5, 1, and 0.5.